going to lose the jacket. It's a little bit warm.
All right, we're good.
All right, afternoon. Jeremy Rassmusen from Abacode. I'm the Chief Technology Officer. We're a local cybersecurity company. I also am an adjunct faculty at USF. I've been teaching classes there since 2000 on cryptography, network security, ethical hacking, mobile and wireless, forensics, and so forth. Started the White Hatters Club back in 2005 to do capture the flag competitions and so forth. So, pleasure to be here with you this afternoon. Insane in the Mainframe is my topic today. I took that from, obviously, Futurama. I don't know if you ever saw that episode where Bender and Fry go into the bank, and then I think Bender's old buddy there robs the bank, gets them framed for it. They end up having to go to robot rehabilitation hospital, where Fry is like, I'm not a robot, and they're like, obviously you're crazy. And so they make him eventually believe that he's a robot. But hopefully it's not going to be that way for you. The gist of this talk is a lot of people are moving to the cloud. Who's on Office 365 already? Who's like moving to Office 365 or, okay. And then who's thought about it, right? So you're already kind of there, halfway. If you're in Office 365, you're already on Azure, because Azure is the basis for Office 365. Who's doing some Amazon stuff? Anybody Amazon? Anybody Azure? Anybody going to Amazon or Azure? Okay, so basically everybody, right? But then, if I asked you to tell me all the security implications of that, how does Azure or how does Amazon or any of those handle security for, let's just say, their virtual machines? Might not know the answer. So when I started out looking at this, I was like, I have a 715-page, I'm not kidding you, 715-page document from Microsoft on this, and I'm like, this is staggering. This is just too much. And that's how everybody feels when they start looking at everything. It's just like too much. So the gist of this talk is to boil that all down into a TLDR 30-minute talk, and this is going to give you the summary of how Azure is trying to do security. Then, it's to motivate you to do some self-study on your own, to go off and, take a look and dig down and deeper into this stuff. But I think this is going to get you started if you don't even know where to start. So the cognitive dissonance there that Fry has is kind of what, so here's what we're going to talk about today. So first of all, I'm just going to give you some cloud background. If you don't know where to start, we're going to help you get started. And I'm going to tell you how Azure does identity and access management, how they do encryption and file management, how they do virtualization and firewalls, networking, and so forth. And then how to kind of get a handle on all that with logging, monitoring, security, scanning, that kind of thing, the stuff that we do as a managed services company. All right, so the cognitive dissonance, I think, for cloud actually is, relevant to what we're talking about for insane in the mainframe. I was thinking about this, by the way, does anybody know what this picture is from? Anybody? Like where? What building? Used to be in the physics. Not anymore. They moved it. This is a giant Foucault pendulum that they moved from the physics building to ISA, the Interdisciplinary Sciences building. But it's pretty cool. If you ever get a chance to go over there and see that, it's really neat to see. But back in the 60s, all the way up till the 80s, we had just mainframes, right? The way you secured a mainframe was by locking the door to the server room, right? We had dumb terminals that connected into this thing. From the 80s to the 2000s, then we kind of went the other direction. The pendulum swung over, and we had distributed systems. We had more technological and electronic means to protect those systems. And now I see it as kind of swinging back over to this mainframe idea again, where the cloud is your mainframe now, even though it's really a distributed system of millions of computers, but it looks like a single system to you. And of course, electronic means and protections to that's what we're going to go over today, is what those protections are available. So why, just without looking at this slide, I already stole my own thunder. Why would you move to the cloud? What are the benefits of that? Yeah, it's not my cloud. It's somebody else's thing, right? Exactly. What else? Scalable. Cheaper in some cases, maybe not. You got to pay for everything in the cloud. Availability, absolutely. 99.9% uptime SLAs, right? It's supposedly greener. There's a lot of things that are cool about cloud, right? That's why everybody's kind of going that route. But why is cloud scary? Well, you're putting all your eggs in one basket, right? When you store your data, Microsoft has 27 data centers on, throughout the world. When you store your data, actually, where does it get stored? I don't know. Not sure about that. And you'll have a hard time actually knowing where it gets stored and who has access. Is it in a country that demands backdoor access, like the United States, probably? To the government. Right. Where's your standing, or where's your contacts for legal standing? Oh, I guarantee it's in your terms of service. You just got to read that. It's not where you want it to be. And also you've got to consider if they have 27 data centers and 1 million plus servers out there, and they're all running Intel processors that got hit by that are affected by Meltdown and Spectre. Wow, somebody could come up with like this killer virus or something that could take down the whole thing, right? So there's definitely some drawbacks or scariness to operating out of the cloud. But Azure, I don't know why Azure. I could have done AWS, Rackspace, whatever. It's just that I didn't know much about it, and I set out to learn more about it. And like I said, there was so much to learn, and I didn't know where to start. So I just decided I'll start looking into this. Microsoft is considered the top cloud provider only because they count everybody on Office 365 as part of their cloud. I think AWS probably sells actually more pure cloud than Azure does, or than Microsoft does. But nevertheless, they're very good. They're very involved in all aspects of software as a service delivery, platform as a service delivery, infrastructure as a service delivery, and we'll go into that in a minute. What does that mean for you? Where does your responsibility begin and end on security in those different models? Also, what I found out from starting to dig into this, they have a lot of interest in supporting AI and machine learning stuff. So if that's something that is of interest, scalable systems to support machine learning, scalable systems to support blockchain technology, they have a lot of dedicated environments for that. So as of right now, they've already sold $17 billion of cloud a year, and now they're talking about selling $20 billion of cloud a year. If I had some extra cash sitting around, I'd probably invest in Microsoft. And I'm not a Microsoft pimp. I'm just saying, they're doing well. All of our customers that we talk to, most of them are moving into Azure or Office 365. And their CEO is very, cloud focused. As I was doing my research, some of the cool things I didn't even know about Azure is that it lets you run Linux containers with Docker integration. So they're not forcing you to go Microsoft on everything. You don't have to do Windows and .NET and all that. If you want to, you can build your stuff in JavaScript, Python, whatever, and they integrate with iOS, Android, all kinds. They want the whole enchilada, right? So they're willing to open up and play with everybody else's technologies, and so they interface with everything. Whenever you're talking about delivering cloud services, it's a complex and difficult task, and so you want to decompose that into sort of like a stack of services, with each layer doing some kind of job. And so it's also important to know who's actually running things for the organization that you're signing up to do business with. And because each layer affects the other layers, and a crash at one layer could have an outage at every other layer, you really kind of got to know who you're working with. So in Microsoft, the GFS, Global Foundation Services Group, is the one who actually runs their data centers and their 1 million servers at the physical layer. Their STB, Server and Tools Business Group, is who does the platform layer. That's all the cloud delivery infrastructure. And then you and us, all of us, are the people that kind of run the applications and data that sit on top of that. So this is kind of the money slide right here. This came from several different documents and places that I gleaned stuff together to try to figure out, all right, what actually are they responsible for, and what am I responsible for in terms of security? So does everybody know about the different levels of software as a service, infrastructure as a service, platform as a service? If you don't know about that, it just means how much stuff your provider is giving you versus how much stuff you're doing yourself. So if you're running your own thing on premises, you're responsible for everything, right? You've got to configure the whole data center. You've got to provision it, run all the operating systems, provision those, do all your identity management and so forth. If you're going with what they call infrastructure as a service, they're going to give you the physical hosts and hardware and stuff underneath your network. All that's abstracted to you. You won't see any of it. But you're responsible for everything from the operating system up. So you've got to configure that, and you're responsible for the security of all that. If you're running Microsoft's platform as a service, they're actually going to also give you, they're actually going to provision all the operating systems and the VMs, and it's a shared responsibility on network application and so forth. And then if you're running their software as a service, so you just have a hosted app there, then they're giving you everything underneath that, and the only thing you're responsible for is the app. But still, there are some security implications of configuring your own app on their cloud. So if you don't know where to start on something, like how do I know if they're secure or not? Well, there's a Cloud Security Alliance, CSA, and they developed a list of security controls they call the Cloud Control Matrix, CCM. And it's all about, you know, how you should do audits, how you should set up personnel, operations, security architecture, and so forth. So anybody that you're doing business with that is claiming to be secure in the cloud should have some reference to the Cloud Security Alliance, CCM. So Microsoft has like a 75-page document that shows how they comply with that matrix. It also actually maps to all their ISO 27002 controls, or 27001. By the way, anybody know what ISO 27001 is? It's an international standard for security controls that you should have in any business process or business infrastructure, IT infrastructure. You have to pay for those ISO documents. So I actually went to USF and got them to buy a set of the ISO 27000 documents. So they own those now. So if you're a student or faculty or you just want to go in there and use your reference materials, you can check those out and for free instead of having to pay ISO money for the standard. Just throw that out there. But yeah, they have a whole document showing how they comply with those controls. And here's what they claim to do. So first of all, they're saying, well, we've built security into our own internal, code base through code audits, mandatory background checks for our developers, mandatory security dev training. This hasn't always been the case. I remember I talked to, anybody remember Howard Schmidt, who was the Chief Information Security Officer of the White House, and before that he was CISO of Microsoft. And I asked him like straight up, hey, in the early days, did Microsoft really give a about security? And he's like, no. He was straight up. They didn't care until like Linux started eating their lunch on some stuff, right? So until it became like a money issue for the company, they didn't really start putting any money into security. So at that point, this is probably about 2000 or so, they had their trustworthy computing initiatives. I don't know if you remember that. It's a long time ago. They had like a coding holiday. We're like, we're going to stop writing code. Everybody's going to stop. We're going to train everybody how to do secure coding now before we do anything else. I mean, they need to do it, right? Because 90% of all operating systems deployed out there are Windows or Microsoft based. So all vulnerabilities and exploits are targeted for them. And so they need to be really good at what they do. That doesn't mean they're perfect, but at least they have the controls in place to try to make their software development lifecycle better. In terms of security operations, what do? They claim that they do regular pen testing of their environment. They have intrusion detection. They have DDoS controls. How do you, to get hit by DDoS, what do you have to do about that? Distributed denial of service. What's the countermeasure for that? Huh? Well, professional service to do what though? You have to have like some capacity to move all the network off to somewhere else, scrub it for DDoS, and then move it back to the right place. I mean, so they must have a lot of internal infrastructure, or either that or using some kind of third party to do that. So they've thought about this, and for availability reasons, they have all this stuff in place. The data centers are amazing. If you go out there and look up like Microsoft data centers, some of them are really cool. They have they're modular. They're like a farm. It looks like a trailer park, honestly. They'll configure a trailer. They'll have all the servers, all the cooling, power conditioning, racks, raised floor, cabling, fiber, and all that stuff. And then they'll just, it's modular, and they just keep adding more trailers to the trailer park. Some of them are actually buildings and stuff like that, but some of them are, they're very, very cool. They've got millions of servers, very strong physical security availability, rows and rows and rows of batteries and battery backup and generators. And like if they ever went down, if there's ever a power outage in that area, probably the hospital gets restored, number one, and then the data center, number two, right? They're on a priority restoration schedule. So, they can deliver this, big time availability uptime. In terms of secure networking, they claim to have, network access controls in terms of firewalls, route control, force tunneling, secure access, cross-premises connectivity via VPN, load balancing, force name resolution either to the Azure DNS system or bring your own DNS. So they've got all that in place. For monitoring, they have threat detection, incident response going on, round the clock always. So they're kind of doing, you don't hear much about Microsoft failing on security at the platform or at the infrastructure level. So what's our part of the responsibility? What do they offer us in terms of tools and controls for controlling security in the cloud? So let's look at identity access management first. This is probably the big selling point for them, right? Their single sign-on. It's considered to be, by people that do such evaluations, Kuppinger Cole puts them at the front of their, SSO. The nice thing is, they've decided to work and play with everybody else. So you can do single sign-on when you get onto your Azure instance. You're not only onto Office 365, but you also can get to Dropbox, Google Apps, and thousands of other things through OAuth and other different SAML and different types of federated identity. They also have they've tried to make it so that you have easy integration with your on-prem stuff. So if you're running, everybody's probably familiar with running Active Directory Windows on premises. So it should be a simple matter, almost like a wizard, click a few buttons here. They claim 4 clicks in 5 minutes to get stuff like transferred and synced up to the cloud. It's not that easy really, but they claim that. And you can get started for free. Everything in the cloud is just like a drug dealer, right? They give you a taste for free, and then once they get you hooked, they're going to make you pay. Basic will give you the SLA uptimes, and then premium. There's 2 or 3 levels of premium that will give you multi-factor authentication and some other features. But I just want to compare. So anybody that's familiar with standard Windows Active Directory on premises, you've got these different services such as domain, lightweight directory, federation, certificate, rights management that run through protocols such as Kerberos. Everybody familiar with Kerberos? It's honestly named for the 3-headed dog of Hades, right? You log into an authentication server, you get a ticket granting ticket, which it gives you a validation to get a ticket for a service, and then you present that ticket for a service. They've tried to bring that over to something called Azure AD, because on premises, we're designed for full control here. We're trying to control everything. When you're in the cloud, we're not controlling physical, we're not controlling infrastructure. The only thing we really care about is identity management. So for Windows Azure AD, Active Directory, all we care about is federation, which means getting to other stuff, and our own identity management in Active Directory. So the fallout from this, unfortunately, is that if you developed an app, you can't just take an Active Directory integrated app from on-premises and forklift it easily into the cloud. You kind of have to rebuild it for the cloud for Azure AD. And that's unfortunate, but that's the reality. So talking about some of the APIs that they use for controlling things in the cloud, Microsoft Graph is a new way. Graph is a new way of controlling access controls for what they call CRUD, create, read, update, and delete. It used to be something called Azure AD Graph API. This is probably a drawback of some of the Microsoft stuff. They're trying to move so fast that sometimes they come out with something, they do it for a couple of years, and then they pull it back and they replace it with something else. So like as soon as you develop to one standard and get used to it, they're like, yeah, we don't have that standard anymore. We're going to move you from Azure AD Graph API to Microsoft Graph. Anybody run into this before? So you have to be very agile in your development to keep up with how agile they are in their development. But CRUD is going to give you, allow you to create a new user. This is just some typical things you might do. Get their properties, update the properties, check the group membership. I'll actually show you how that all works with an example. All right, so here's how you would configure an app. You simply create a service principal and a tenant. Tenant is the same thing on any cloud, right? Tenant is your instance. So it's the same, if you're running on AWS or Rackspace or Salesforce.com, whatever, you're going to have a tenant. That's your instance. So a tenant is your instance in Azure, and then your service principal is really your object that talks about what you're providing for that application. And it's going to have an identifier and a key, or a secret. They'll also have a little database of user data that will tell what, like maybe for role-based access control reasons, what what the role is, and data for the app. So then, to get started, you give that app a URL, an address. To get to it, they just browse in through their web browser to the URL. It redirects them to the Azure Active Directory login page. So you log in with your user ID and password, or multi-factor authentication. Then it uses a token signed by the Azure AD, which goes to signature validation. So they make sure it's legit and signed by the certificate authority. Then the app checks the ID against the app database, and maybe either using the secret from the object or some security context settings from your database, it lets you get to the thing you want to get to. Nice thing is, we never passed the password, right? We did all this with a token. So that's the beauty of single sign-in. Anybody use like LastPass or any of these tools? You've got like 80 different things you got to get to. Everyone has a different password. The holy grail of computing is single sign-on, where I only sign in one time, and then I pass a token to everything I want to get to. That's what they're trying to do. All right, so that's identity access management. What about controls on files and encryption? What do they offer there? Well, as I mentioned before, I think multi-factor authentication is super important. Whenever we do a pen test or whatever, the easiest way in is phish somebody, right? Either call them up and ask them for their password, which they might give you half the time, or send them a phishing email that looks just like their domain, and they go to log in and you grab their credentials. Multi-factor authentication, obviously, now you're sending them a text message, or they're having to click on something on their, an authenticator on their mobile device or whatever. That makes it a lot harder to just steal credentials. So I highly, highly recommend that. If you don't have that implemented for everything across the board, you should turn that on. And Azure supports that everywhere. You should try to restrict access based on, need to know and least privilege. Whenever anybody comes into your organization, you should give them the least amount of privileges they could do to, do their job and no more. Role-based access control through, groups, very familiar in Windows, is a standard part of Azure. Azure actually has disk encryption. What do you think it uses for disk encryption? What do you use on premises? BitLocker. What do you use in the cloud? BitLocker. Same thing. So what do you use for Linux for disk encryption? DMcrypt. What do you use in the cloud? DMcrypt. Yeah, same thing. So it's virtual, but it's the same thing. It's really the same type of thing. BitLocker and DMcrypt are used for disk encryption in Azure. And they actually have a tool called the Azure Key Vault that helps you control all your BitLocker keys and DMcrypt keys. It even has some features like key audit. So you might like to get rid of old keys after people leave the organization, or roll them over after some certain amount of time. You can do audits on that and update all that information through the Key Vault. It's also got something called Pause, which is a high assurance workstation. So there's like certain things you're doing for admin reasons. You might not want to just do those on a regular workstation with lower security privileges, because again, you've got the whole credential theft thing. So many systems we set up, it's easy to set up a responder, do a little bit of cache poisoning, or get, force traffic to your system that's, they don't have any way to resolve NetBIOS names, things like that. And you can steal credentials, or you can do pass the hash or pass the ticket attacks, or, somehow get a keystroke logger on there. It makes it a lot harder with Pause because it's a high assurance workstation with more protections to harden, lock down, keep people from being able to do those types of credential stealing attacks. A real nice thing about Azure is its SQL database transparent data encryption. Now, this should be, this is, in this day and age, how you are not encrypting your database is beyond me. I mean, Equifax. Yeah, I mean, when people are getting into your system and they're able to get to plain text data, it's just incredible how that happens. But through a SQL database TDE, transparent data encryption, it helps lock down the data, and also has some tools in there for backups, even encrypting backups, transaction log files, and so forth. So it's all built in. Everything in Azure is SSL TLS encrypted. So site-to-site VPN, point-to-site VPN. Anything going to storage is encrypted. Anything within the infrastructure of Azure is encrypted. If you have a dedicated high-speed WAN like Link, like ExpressRoute, all that's encrypted. Any contacts through connecting up to an API, a REST API. It's all done over HTTPS. So every single thing in there is data in transit encryption. And then, you can even do file level encryption for data at rest. So it's got lots of encryption everywhere. As I was researching this, I thought I'd tell you this little late breaking news tidbit. I didn't even know about this. It used to be that when people could, did Azure search, they could actually bring up, look for keywords in documents, and it would bring up documents or partial findings from documents, and you could infer based on their search results what the contents of the document were, right? They took that away now. Now everything's encrypted with AES 256-bit and role-based access control. So if you try to search on something, you're not even be able to bring up results from stuff that you don't have access to at all. So anybody who's running Azure, if you've done your indexing prior to January 24th, you don't have this yet, but you should just make sure you do. You should re-index to make sure you get that encryption, and it can't be turned off. It's controlled by Microsoft. All right, so everybody, I don't know, one of the difficult things for my students in classes, I don't know why, they're junior and seniors in IT, and I have the simplest assignment, I think, which is install a virtual machine, like install VirtualBox and Kali Linux and get that running. And I have to do help session after help session to get them, because it's just so hard. They just don't understand it, how to, it's evidently fraught with lots of difficulty for some people. But, so they don't even understand the very basics. But virtualization is you have a host OS, and you've got some virtualization software that runs a hypervisor, which is what enforces security protections between the host and the guest, and you run a guest operating system inside the virtual machine. All right, that's about it. So how does Microsoft do all that? Well, there's three things they do. They have protection for the virtual machines themselves, they have isolation of processes, and then they have network security. So VMs, in general, like I said, you have your host OS, hypervisor, and guest OS. The VMs never have access to any raw, read-write privileges on physical software, right? That's protected. That's actually firewalled by the software. By default, the app Azure firewall, hypervisor, or whatever you want to call it, firewall, it will block all traffic from the VM to physical ports, and only let them get to virtual ports that are locked down. The things that we'll let it do is like maybe go to DHCP so it can get a local address, or maybe go out to the internet, or maybe talk to other VMs in a cluster. But absolutely everything on the back end, Azure router, subnets, management back end, that's all blocked by default. There's absolutely no way to get to it. There's also memory and process separation enforcement. So anybody remember the early days of VMware and security enhanced Linux, SE Linux? We're all about trying to do process enforcement. I remember I worked on a project with NSA way back in the day called NetTop, where they're trying to run different virtual machines of multiple levels of security, secret, top secret, and different flavors of coalition networks all in one box. And it was using SE Linux with a modified VMware hypervisor to try to block, cut and paste from one classification level to another and things like that. Well, this is all, standard for virtualization now. Now, I assume, like we know that they're using a virtualized version of BitLocker. I didn't really look at this. Does anybody know the answer to this? They use a virtualized version of BitLocker for their virtual disk encryption in the cloud. Do they use Hyper-V for their hypervisor security, or have they come up with something completely new? I don't know the answer. My guess is, since they don't mention it, probably using VMware. Just guessing. But they also do separation through, private IP addresses, NATing, firewalls. Actually, there's firewalls everywhere. Think about this. All right, you've got your physical layer, then you've got your host OS layer, then you have your hypervisor, and you've got your VM, and you've got the operating system that's the guest inside of the VM. You've got firewalls on all of those, every single place. So at the native level, your Azure Service Fabric has firewalls and keeps you and protects storage and VPN. At the host level, there's a firewall that protects the operating system in the that runs the hypervisor for the hosts. When you go to the like the Windows, when you go to the Azure storefront or whatever you call that, and download your operating systems, your Windows OSs, those all come with Windows host-based operating system turned on by default. When you try to get storage, everything is blocked by a front-end firewall server. When you do VPN, there's a VPN firewall server. So there's firewalls everywhere in Azure. So you would think with all these firewalls, it's going to slow stuff down, right? Every single place you're getting your packets checked. But, they have this, fabric that's interconnected. They have high-speed networking, so everything's, they try to speed it up with high-speed equipment. All right, so we got identity management, which is, big deal, basically letting you federate your on-prem with your cloud and federate with other outside services like Dropbox, Google Apps. You've got your encryption, your file control. You've got your access control. You've got your VMs under control now. How do I make sure it's all running correctly? Well, I would like to have some way to monitor it, lock it down, assess it, scan it, right? So here's what they have for that. They have something called OMS, first of all, which is their operations management suite. So it's really a collection of tools that lets you do log analytics, automation. It lets you spin up VMs. It helps you watch things. What I like about it is you can even use it for some on-premises operations. So you just put an OMS agent on any Windows or Linux box on your on-prem or in your data center, and it will send data to the log analytics for central analysis along with your cloud-based stuff, right? All in one place. Helps with backups, site recovery, and all that stuff. Here's what actually OMS looks like if you log in. I'm sorry, it's hard. This is not that great of graphics, but you can see, you can't see. I'm even standing right by it. I can't read it. But I'll tell you what it says. It tells you that there was X number of systems to try to connect out to a known command and control malware site, that there's X number of systems that aren't properly provisioned for some patch. So there's some, in addition to the health and network status stuff that Azure delivers, it also gives you some security stuff. In addition, it's got something called Security Center. And this is basically, you can set up a security policy for all of your VMs, and then you go check them all at once. Think how powerful that is. If you're running, say, enterprise with 2,000 endpoints and 100 servers or whatever, all at a glance, a couple of buttons, press out a policy to all of them, and then a couple more buttons, audit all of them, and see how they're doing. So it's as simple as log into the portal, go to set up a security policy, go to the policy components section. You're going to see the default policy that it rolls out when you first deploy the VM, and then you can just turn on or off stuff and hit save when you're done. Here's all the stuff you can do. Here's all the policies you can set. So you can set it up for automatic Windows updates or Linux distribution package updates. You can look for system misconfigurations within the VM. You can make sure they have antivirus installed. This is just like on Windows 10 on your desktop. If you go and you don't have any antivirus, it's going to be like, hey, you really should have something turned on. And then you install like AVG, and it's like, hey, you really should have something else turned on besides that. A lot of these things actually is Microsoft trying to sell you stuff, right? Because they're going to say, oh, you need this, so go pay us some more money and get it out of the App Store. Disk encryption, they want you to turn that on, BitLocker for all your VMs. Security groups, firewall, they want you to have that turned on. I told you some of these things are turned on by default. SQL auditing, and obviously if you're running a database, you should have that turned on. I can't imagine why you would have that not turned on, other than, negligence. Telling you should have some kind of vulnerability scanning set up and encryption. This whole thing with the just-in-time access, that's really, by creating a network security group rule, you select the ports on the VM to which inbound traffic should be locked down, things like that. So this is all the stuff they're telling you should have, and then you run a scan through if you click on the prevention tab in the security center, it takes you to something that looks like this. So it shows you all at a glance. Okay, here's how many compliant, here's how many non-compliant. There's 7 with high severity. Those are the ones you got to look at first and remediate, right? So it's pretty powerful. That's good. But full disclosure, I'm not necessarily an IT operations guy. I started out in software development, started getting into crypto boxes, teaching classes, auditing. So I like to break and audit stuff. I'm not necessarily running stuff. So as an auditor, I wanted to know what could I do to audit all that as a third party. Obviously, for vulnerability assessment reasons, pen testing reasons, I'd like to see how somebody's doing with their Azure security. So this is kind of another slide I'm proud of because I have figured out how to actually run Nessus with Azure. And it sounds like, who uses Nessus vulnerability scanner? Like half the people, right? But if you try to use Nessus to scan cloud configurations, it's not straightforward. You have to do some finagling. I decided not to show this in real time because real-time demos are always fraught with danger and fail. So I'm going to show you some screenshots and talk about it actually. But here's what happens. Number one, you go to the Azure portal, and you have to you click on the Azure Active Directory. I know you can't read this, and this is hard to see. And then you go to app registrations, and you click on that, and you create a new app. So remember we showed that demo earlier, which is it's really an instance, what they call a service object. It's going to have a name and some secret. Well, when you click on that thing, when you create it, and I'm so sorry you can't see this, it comes up with two fields, one that says application ID and one that says object ID. The one you want for Nessus is the application ID. Now, when you go into Nessus, it tells you it wants something called a client ID. Don't know what that is. I think back in the day, Azure used to call that thing a client ID, but now it calls it an application ID. If you don't use the right one, if you try to use the object ID, it's not going to work. All right. So what Nessus asks for, calling it a client ID, they're really asking for application ID. So you create that. You can call it anything. You call it junk. Give it a URL, junk.com. And you want to copy the application ID. Then you go into settings, and you have to click on required permissions. This is also very important. And I really didn't find this in necessarily any Nessus document. You want to click on required permissions, and then you click on add in Windows Azure Service Management API. So you've got to do this to give basically the object API access from the outside in to be able to scan your network. But by the way, what I'm describing is I have an instance of Nessus set up on a server in my data center, and I use that to scan things. And so I'm giving it access through an API key or whatever to get into Azure and scan this cloud instance. You could actually do all this in Azure itself. There's in the Azure App Store, there's a Nessus tool, and it's like bring your own license. Just provision it with your license, and you can do it from right inside Nessus, but I'm not going to show you that. I'm showing you the way I did it. I would say this is similar to how you do AWS scanning tool, too. I just did some of that recently. You have to set up a key, a separate secret key for AWS to be able to scan. You can't just log in with your user ID and password. All right, be careful with those. What you've done is created this API key that has admin level privileges. So I'd say after you've done your scan, throw that thing away, disable it, deprecate it. Don't use it anymore once it's not in use or not needed. All right, so let's take a look. Oh, you can't see that, but it says make sure you get application ID, not object ID. All right, so here's actually Nessus. I don't know if the Tenable guys are here today or not. I actually saw someone out there, but if you go into Nessus and you start a new scan, you select audit your cloud infrastructure, and that brings you to a dialog that says you have choice between Amazon, Rackspace, Salesforce, or Azure. So I'm going to select Azure. Then I'm going to put in my credentials here, and the key thing, application ID right there, even though it says client ID, whatever that is. Then you have to tell it what you want, what compliance standard you want to scan to. So they have some choices there. They have an Azure Best Practices one. They've got one specifically for websites. They have one specifically for database. Whatever you want to scan for, select your compliance thing and put it in there. And then you scan, and boom, you get some results. Now, I didn't really set up a real instance. It didn't have a lot of data or anything in it. So most of these warnings are, hey, this certificate doesn't exist, and there's no virtual machines that exist. So I don't know what we're really scanning here, but if I did have some VMs in there, you would probably have some, some fails and some warnings. Most of the things have to do with have you correctly provisioned the VM in terms of security settings? Do you have strong passwords? Do you have monitoring and logging turned on? Stuff like that. So anybody know what a SIEM is? Security Information Event Management? Anybody run a SIEM? Security Ops Center? SIEMs are super powerful. We're partnered with, a lot of them. Logarithm, Alien Vault, Splunk, QRadar, things like that. What it does is it takes all of your like firewall data, network IDS data, server data, and puts it all into a correlation engine and runs these rules on it. Some of these have like 150,000 rules out of the box. They're constantly updated with the threat feed, and it helps you see how secure you are. So you can actually use a SIEM to not only monitor your VMs, what's going on inside those, but also monitor the health and status of your Azure environment. And all these SIEMs have a plugin specifically for Office 365 and Azure cloud stuff, as well as Google Apps and AWS and so forth. So the beauty of that is that you can, they've got all these rules pre-built and integrates with your firewall. It's updated with an Intel feed. You don't have to actually write all the rules yourself if you don't want to. There's some you might like to customize. But key point is you don't want to monitor all that yourself, right? I would recommend, obviously, selfishly speaking, go with a managed service like ours because SIEM is very noisy. It's like a little kid. It always wants your attention. Here's my example I give everybody. If you bought this, there's a company, hope they're not here, friends of ours, good buddies, but they bought a SIEM. First time we ever went in there, we logged into their console, and they had 90,000 unattended alerts. So it's like you bought this product, you're paying $30,000 a year for it, and nobody's ever watching it. Or it's noisy and gives you so many alerts that I can't take it. Stop, and then you just start ignoring all those alerts at your own peril. So best to go get somebody who will go through all the alerts, triage them or escalate them according to some incident response protocol, and take care of that for you, take it off your plate. Otherwise, you're going to buy this nice tool that's going to do nothing for you. So that's about it. I mean, finally speaking, I think we know cloud isn't perfect. Azure, Microsoft. I don't know if you can read this. This is a story from last year. They had an Azure outage caused by a fire suppression gas release. I know one of the earlier speakers who was speaking about Zillow said he had a fire suppression vulnerability. I wonder if that's related at all. Just guessing. But anyways, they were down or they had glitches for like 7 hours. So if you've put your eggs all in that one basket and you're down for 7 hours, you're probably sad. Oh yeah, that's the little trailer server farm I was telling you about. So I mean, it's not perfect, but the nice thing is, and they also charge you for everything. Anything you want, it's going to charge you more. They're going to, if you want to add DLP, hey, we'll do that for you, but it's going to cost you. But the nice thing is, there's a lot of nice centralized security features for identity management, for file encryption, for auditing, logging, and for getting control of your security environment all in one place. And you can take advantage of that. So, as I say, pimping my own self again, let a managed security partner take care of that for you because it's not something you want on your plate. Absolutely. So I hope you're smarter about Azure security now. Take a few questions if anybody has any. Wow, you're enlightened. That's awesome. You're completely enlightened. Well then, right. Exactly. Any Azure security questions? No? All right. Any questions about cryptography? No, whatever you want to ask me. Go ahead. Changes in permissions where they logged? So, yeah, there's centralized logging within security with the security center. So, question. Question is about SIEMs. So security information event management solutions. You take a port mirror off your firewall and you feed it into the SIM. You also put an agent or pull logs from Windows systems or Linux boxes, critical servers like file servers, database server, web server, DNS, and everything like that. You also put an agent or pull logs off of all of your critical infrastructure like router, switches, and so forth. All those events get poured into one aggregation server. So thousands of events per second, maybe even per second, depending on how large the environment is. Then the SIM, the brains of the SIM, is that it runs these correlation rules, algorithms, continuously over everything and determines if something looks like an intrusion is happening, if there's some security alert that needs to be taken care of. A lot of times they're false positives, or there's something we've seen before. It's just a matter of understanding the environment and triaging it. But a lot of times those things have to be taken care of immediately and spring into action. So, oh, this guy's connecting out to a command and control site. We know he's infected with malware. Let's shut that box down, or let's put a rule up in the firewall to block it. So there's some simple things you can do for incident response right off the bat. Last question?
You talked about OMS agent on your server. Can you directly where those agent requests
Yeah.
go, or does that have to go back to Microsoft aggregation?
No, you can. I believe you can direct that not to the centralized logging in the cloud. You can move that to wherever you want it to go.
So if you have an isolated enclave, you can still make these agents.
I believe so. Yep. And a lot of these SIMs actually have an agent that they use with them too. For example, Alien Vault in the past has used OSIM, open source SIM. They're actually talking about. We just talked to their development people. They're on a roadmap to create a new agent. So you have to look out there and see what kind of log pushing agents there are available and how those work. All right, thanks a lot, guys.